Part A, I'm going to take logarithms of both sides, just the general log base 10. You could do any other logarithm if you prefer. So that's taking a logarithm of the left-hand side, taking a logarithm of the right-hand side. I'm now going to use the laws of logarithms to bring the powers down to be coefficients. So I've got x times log 2 is equal to x plus 1. Make sure you keep brackets around those two terms from the power, times log 3. I want to make x the subject here, so I'm first going to expand the brackets on the right-hand side. So there I've just done the x times the log 3 and the 1 times the log 3. Moving all of the x terms to the left-hand side, so I'm subtracting x log 3 from both sides. Factorise the x on the left-hand side. And now I'm going to divide both sides by this log 2 minus log 3, so that I get x as the subject. So x is equal to log 3 divided by log 2 minus log 3, which on my calculator to three significant figures gives minus 2.71. So that's part A done. Part B, same idea. We're going to take logarithms of both sides. And then going to use the laws of logarithms to bring these powers down. Making sure I keep brackets around the y minus 1 because there's two terms in that power. I'm going to expand the brackets on the left-hand side here, so y times the log 3 minus 1 times the log 3. And now I want to collect up the y terms on the left-hand side and the terms that don't have a y on the right-hand side. So I'm going to collect these together on the left. And I'm going to move that term there over to the right because it doesn't have a y in it. So y log 3 minus 2y log 2 is equal to log 3. So these are the two green terms on the left-hand side. This is the yellow term on the right-hand side. Factorise the y outside. And now divide both sides by this bracket to make y the subject. So y is equal to log 3 divided by log 3 minus 2 log 2. If we put that onto in our calculator, to three significant figures, we get minus 3.82. And that's my answer to part B. Part C. Same idea, we're going to take logarithms of both sides. So taking a logarithm of the left-hand side, taking a logarithm of the right-hand side, and use the laws of logarithms to bring the powers down to be coefficients. Making sure that we keep the 2z plus 1 as in brackets because there's two terms there. Next step, I want to expand those brackets. So 2z times log 2 plus 1 times log 2 and now I'm going to collect up all of the z terms together on the left hand side. So I'm going to move this over here to group it together with this. And I'm going to take the log 2 away from both sides because that doesn't have a z in it. So 2z log 2 minus the z log 7 excuse me, is equal to minus log 2. Factorise the z outside. And now divide both sides by the bracketed term to make z the subject. And if we put that into our calculator to three significant figures, we get 1.24. Then part D, same idea again, take logarithms of both sides. We'll then use the laws of logarithms to bring these powers down so that they're coefficients. Making sure we keep brackets around that 2w minus 1 because there's two terms there in the coefficient. Expand those brackets. Now I'm going to collect the terms, the w terms together on the left hand side. So I'm going to subtract this from the left hand side so the w's are together. Leave the minus log 3 on the right hand side because it doesn't have a w in it. Factorise the w outside to get 3 log 4 minus 2 log 3. And then divide both sides by the bracketed term to make w the subject. So I'm dividing by 3 log 4 minus 2 log 3. And if we put that into our calculator, we get minus 0.56. That's the three significant figures, 0.